So the question was, we've been talking about matter and antimatter and dark energy, and do we actually know what any of those things are? Is that the question, basically? So right now our best understanding is the cosmologists tell us that the universe is composed of roughly 5% matter and energy, something like 20% dark matter. Does that sound about right? Yeah, 20, 25. And the rest, the 75%, is this stuff called dark energy. Now, we think we understand the matter part of it pretty well. That's the stuff that, that you and I are made of, the normal matter. This also includes the stuff that we call antimatter, and we understand antimatter okay. When a physicist uses the term antimatter, they're referring to something that has been observed that we do understand. So, like for instance, your typical atom is composed of protons, neutrons, and electrons. Well, the electron has an antiparticle, which we call the positron. It has the same spin, but it has the opposite charge. It's a +1 charge as opposed to a -1 charge. Those have been observed. Okay, and so that's what we mean when we say, antimatter. The business with dark matter is unclear. We don't know what that is yet. We think we know what some of it might be. For instance, I mentioned these neutrinos way back at the beginning, that we now know they have mass. They could form part of the dark matter. They could explain some of it. They're essentially dark because they do not like to interact with things. They're very hard to detect. So they could fall under the heading of dark matter. But a lot of that, no one really knows what the dark matter is. I know I've heard some astronomers say it could be things like undetected black holes, this thing called machos, massive compact halo objects. So it's possible that at least some of it is just normal matter that we just can't see. But it's very likely that there's probably something new there, some new particle that no one has detected yet that explains that. So I would say the significant fraction of dark matter, no one really knows what it is. And then dark energy, no one has a clue. And they say cosmological constant or maybe a different theory of gravity, but it's such a new phenomenon, no one has any real understanding of what that is. So I think it's very interesting that basically, in the entire universe we see a lot, we understand maybe 5 or 10% of it, and the rest of it is utterly foreign to us.
Can I talk a little bit about dark matter? Because dark matter I'm working on a project that's related to dark matter in galaxies, and really the main evidence we have for dark matter is just how fast parts of galaxies move. When we look at the stars in galaxies, they're moving too fast. And the only explanation we can have is that there must be more mass there than we can actually see with our eyes. That's really that's where the evidence for dark matter came from. Back in the 1960s, people started looking at these how fast the stars move in galaxies. So our belief in dark matter is that the particle that makes it up, it's like you said, it has to be a new particle, and the general term we call them is weakly interacting massive particles. They have to have mass, but they're weakly interacting because the only significant interaction they have is gravitational. We only feel their gravitational effect. We can't see them. They don't emit light, so they don't have an electromagnetic interaction. Yeah, Vera Rubin in 1970, she looked at the Andromeda galaxy. That was really one of the first key observations for an individual galaxy. Actually, going back to the 1950s, there was, I can't remember his name, another famous astronomer who looked at clusters of galaxies, where you have lots of galaxies in a cluster gravitationally bound to each other, and he was looking at how fast the galaxies are moving compared to each other, and realized that cluster also has a lot of dark matter. Like the stuff we see is only 10% of the stuff that's there.